Assalamualaikum and good evening. My name is Azmi bin Zadi Anwar. We are from Group 5 and we chose Selangor as our project.
This is our members. First members is Zaid Azmi bin Zaidil, Juliana binti Muhammad, Nurhafiza binti Muhammad Saleh, and myself, Nushaida binti Hussein. In this content, we have introductions, methodology, data presentation, data analysis and results, and conclusion and discussion. Malaysia experiences year-round mild temperatures and heavy humidity due to its equatorial environment. Flooding can occur as a result of both high-intensity, short-duration localized rainfall and moderate-intensity, long-duration rainfall that covers a wide area. Flood records additionally indicate a seasonal pattern regarding flood frequency. When the northern monsoon is in full force, floods most impact the east coast and southern portions of peninsular Malaysia, Sabah and Sarawak. Flooding develops as a result of ongoing, widespread heavy rain, leading to an excess of runoff and taking over streams and rivers. Huge areas of ground frequently flood. So these stations are located at Sungai Bernam Sungai Air Tawar, Idas Sungai Air Tawar and Bakar Nakoda Omar. Flooding appears to have happened more frequently in recent years. Two of the main causes of flooding in Malaysia are increased runoff rate brought on by urbanizations and a decrease in flood storage as a result of development encroaching on and occupying drainage corridors and floodplains. The goal of this project is to use rainfall and water level data from the station Sungai Bernam Sungai Air Tawar district in Selangor to determine the unit hydrograph, the river's discharge at its highest water level, the peak flow of the proposed catchment location, and the average yearly rainfall of the proposed catchment area. Hydrograph or particular parts of them such as peaks grades are frequently used in the planning and construction of water control systems. They are also used to show how changes in land use and current and future watershed activities may affect the hydrologic system. This objective may have to determine the mean yearly rainfall of the selected catchment region. The next one is to measure the maximum river discharge and peak flow at the chosen watershed location at the highest water level. The last one is to calculate the unit hydrograph and plot it for the suggested catchment region.
Hello, my name is Azmi bin Zadi Anwar. My matrix number is CF220138. So today I'm going to talk about the methodology of our project. We do the research using this official website Department of Irrigation and Drainage. So this is the hydrological station map. We use this map to observe which station we should choose to do the research. The hydrological data of the rainfall and water level stations across the proposed area, which is Ulu Bernam, is collected and recorded in the form of hydrographs. The hydrographs have shown that the rainfall data and three stations, which are Bernam River at Tanjung Malim, Bagan Nakoda Omar, Sungai Air Tawar at Hulu Selangor, Malaysia, for 7 consecutive days from 10 December 2023 to 16 December 2023. These are the rainfall and water level stations that we choose around the Sungai Bernam area from the website. These are the three stations that we choose from the Sungai Bernam area. The first one is Sungai Bernam Station, the second one is Ilda Station, and the third one is Bagan Nakoda Station. So this is the catchment area that I made from all the three stations that we choose. We made the catchment area by using the Google Earth Pro. This is terrain profile and gradient slope for path 1, which is Ildas to Sungai Bernam. So the terrain profile and gradient slope for path 2 is at Bagan Nakoda Omar to Sungai Bernam. So the terrain profile and gradient slope for path 3 is at Bagan Nakoda Oma to Ildas. So I choose to take three cross section of Sungai Bernam, which is cross section 1, 2 and 3 and 3.
For the data presentation part, we collect the rainfall data and water level from the official web of Public Info Banjir. We collect the data from three stations which are Benar River at Tanjung Malim, Hildas Sungai Air Tawar and Bagana Kode Omar. We collect the data from 10 December to 6 December. For Benar River at Tanjung Malim, out of the 7 days, the maximum rainfall was on 11 December, which was 63.5. For the next station, we retrieve the data is Ildas Sungai Air Tawar. We also retrieve the data from 10 December to 60 December. Out of the 7 days, the maximum rainfall was on 3 December, which was 55.5. For the next station, we retrieve the data is Bagan Kode Omar. We also retrieve the data from 10 December to 60 December. Out of the 7 days, the maximum rainfall at Bagan Kode Omar was on 12 December, which was 59.5. Moreover, the hydrograph of the water level station that we collect, which is in Sungai Bernam di Sungai Air Tawar. From the water level that we collect, the maximum water level is 0.47.
Data analysis and result. This is the data for rainfall for 7 days. The rainfall data at Station Sungai Bernam is 89.5, Station Ildas 118.5 and Bagana Kode Omar 141. This is comparison between method arithmetic, Thiessen and isohydrate. The precipitation that we get are 16.61, 33.41 and 34.38. Next is peak flow using rational method. The maximum rate of discharge during the storm runoff period is known as peak flow. We can use rational method. To determine this, we need to find catchment area, runoff coefficient, peak discharge and rainfall intensity. This is the catchment area that we get from Google Pro. Next is runoff coefficient. We can use this formula to find the runoff coefficient. The runoff coefficient that we get is 0.767. Rainfall intensity. Rainfall intensity that we get is 38.71 mm per hour. Next is peak runoff. Peak runoff that we get is 2215.25 mm cube per second. Next is discharge of each cross section. For section 1, discharge that we get is 368812.62. Section 2, 361863.65. Section 3, 54296.61. Total discharge that we get is 784972.88.
Next is the part of the hydrograph. In Sabak Bernam Selangor, the channel is assumed to have a trapezoidal shape, and the Meddy method is used to determine the discharge. For the unit hydrograph of upstream, the total discharge that we get is 442783.01, while the total direct flow is 5691.37. Then, for the unit hydrograph of midstream, the water discharge and direct flow was calculated. For the unit hydrograph of midstream, the total discharge that we get is 281905.68, while the total of direct flow is 3586.37. For the unit hydrograph of downstream, the water discharge and direct flow was calculated. For the unit hydrograph of downstream, the total discharge that we get is 52831.26, while the total of direct flow is 691.91.
Floods tend to occur in Malaysia during the northeast monsoon season, impacting beaches in Peninsular Malaysia, especially from October to March. In light of these concerns, we undertook a study on Malaysia's expanding flood crisis. flood hazards has been rising significantly during the last few decades, which can be ascribed to changes in the hydrological system caused by human activities. In this study, we can also suggest how to reduce floods. Besides, we study about the rainfall. To effectively reduce the flood risk, there are multiple strategies that can be implemented at various levels. At the local level, it is crucial to develop and implement an effective flood forecasting system that incorporates advanced weather monitoring and river gauge. This system should provide accurate and timely information to communities, allowing for early warning and prompt evacuations if necessary. Besides that, land use planning also plays a vital role in flood risk reduction. It is important to avoid construction in flood-prone areas and implement sensible zoning regulation to limit development in high-risk zones. By doing so, vulnerable communities can be protected from potential flood damage. Flooding can occur for a variety of reasons, whether they are natural or man-made. It is most important to analyze Malaysian floods to determine whether an area is prone to flood so that preventative measures may be carried out, thus decreasing flood damage and accelerating the rehabilitation process. The research case location is Sabak-Bernam, Selangor, with the goal of investigating a region in Malaysia that commonly suffers from flooding problems. Three rainfall stations, Sungai Bernam, Itas, and Bagan Nakoda Omar, as well as a water station, Sungai Bernam, were monitored for 7 days. The, essen- the essential data is also gathered official hydrological websites such as DID, Department of Irrigations and Drainage. As a result, public awareness and education will be implemented to raise community understanding regarding flood hazards, disaster preparedness, and water conservation practice. Natural water retention features such as forests and meadows must also be restored and preserved since these ecosystems absorb and restore water, decreasing peak flows and preventing downstream flooding. Finally, urban planning must be enhanced by protecting natural drainage patterns and avoiding development in flood-prone areas.